Hello everyone, this is training an AutoML Walking Group community call on 6th of August. This meeting will be recorded and published on YouTube, but this meeting is governed by the CNCF Code of Conduct. Welcome everyone. We have very exciting things to talk about this call today. But before we get started, do we have any kind of new people here in the call who just would introduce themselves? Just want to say hello. Feel free to unmute yourself or use chat to just, if you want to introduce yourself before we get started.
Hello everyone.
Yep, hi Akash, you can hear you. Yep.
Yeah,
Do you want to introduce yourself? Just say hello and
sure. So, hello everyone. I think I've joined call multiple times. Today, I have something exciting to share, which is basically about my GSOC project, where to support LLM blueprint for training. Yeah, maybe during this call, I'll explain what we are trying to implement and what we have implemented. So, sorry for that.
it's great. Thanks for joining. Yeah, really exciting to, have the first work in the GPU infra for Kubeflow projects. I think this is, very important for us. And, looking forward to, make it as a reality for at least for one project under, this ecosystem. Anyone else want to say hello before we get started?
Um, Hi everyone, my name is Radostin and I'm also joining for first time here. I'm a PhD student here in Oxford and my research is focusing on checkpoint restore of GPU accelerated workloads, and I'll speak more about this later today.
Definitely. Thanks for joining, Radisson. Really appreciate it, the time to talk about it. Looking forward, to explore this more and how, this could be useful for, specifically the GPU workloads, the one that you're working on. Yeah. Anyone else before we get started? Um, Hi, Peter. Thanks for introduction. Thanks for joining this call as well. All right, then let me then share my screen, then we can go over the agenda items quickly. Um, Yes, I think we have few topics to talk about. I think the most important one is like I want to share an updates. So quite recently, I don't know if you saw the announcement but the Kubeflow trainer got accepted in the PyTorch ecosystem. So right now we like the part of broader PyTorch ecosystem of the project. So what does it mean for us? Right now we within the PyTorch landscape. So this is like kind of like all the project has deep integration with the PyTorch. So you can see, like SGLang here, VLM, or any other projects like, PyTorch Lightning. And we can see here right now we have a trainer here. So the goal is like, I think I talked about it yesterday, but the training operator slash, TensorFlow operator and PyTorch operator was in Kubeflow for a very long time. So we started the TensorFlow operator back in 2017 when Google open sourced it. Then PyTorch, then we started to do some development with PyTorch. We created the PyTorch operator, and then we merge all those operators together to unify training operator. And right now, like the next iteration of the trainer, where we kind of migrate into the more kind of job set based solution and have like more flexibility. So we have like a long history, within this project, and also we have a long history to run PyTorch flows and Kubernetes. So I think for us, it's definitely a good start. And I really wish we can work more closely with the PyTorch community to make sure like all the libraries and all the development they do within the PyTorch uh, works perfectly on Kubernetes. So our goal is to provide provide the Kubernetes native solution to run PyTorch workloads. And I think like, with this, we definitely can work more closely with them and make sure we aligned like, what kind of things they should do on their side and what we should do to adopt those, new technologies. So if you want to take a look, like we prepared this blog post, which got published 2 weeks ago, actually last week. So we just, give an overview of the project, how, people can get involved. So looking forward to work more closely with them and to see how we can expand, the PyTorch functionality on top of Kubernetes. Any questions for this so far? All right, great. So, yeah, I think like I also want to tell that I think last time we discussed the roadmap. I think we committed let me maybe make a link. Um, so we added this roadmap we finalized the roadmap for 2025. Thanks everyone who participating and give your feedback. I think we have like a lot of exciting things to talk about, and we have in the roadmap such as the gang scaling support, new runtimes, and the build trainers for LLM fine tuning. Also, like the things that we want to talk today is about the checkpointing. We added this in the roadmap items, so I wish we can at least discuss today what is the potential for us to integrate within the checkpointing, and because I think like eventually this is very important feature for us to have. So definitely like take a look on the roadmap. I think we have a few items there. But Ricardo, want to say something? Like I think we can hear you. You want to say something? I think we also can hear you right now. All right. All right, let me add these items here to the roadmap then for the 2025. So definitely let us know like from the user perspective if you want to see something within the trainer, like if we miss some of the items here. But I think overall it's like we have like quite interesting features we would like to support. So definitely get involved and let us know if something we need to expand there. So then I guess like we can directly jump to this discussion around like the checkpointing and like why like what kind of integrations we could have there. So before we get started, like maybe I just want to maybe ask, so how many of you actually try to see what is cryo or like what is like, did any of you actually explore like the talks we saw in the KubeCon, like from different folks who try to adopt this technology on Kubernetes? Um, Yeah, so just to give you like the context like around this, like what is the problem is about, like and what we want to talk about, like the eventually like the in the distributed training environments, there is a problem like how we can we can ensure that like the workloads are resilient and we can provide an infrastructure for users to have an ability to checkpoint in their work, because like the problem that we saw for like many years, that especially for long running training workloads, sometimes if you have like node failure, or if some of the Kubernetes control plane goes down, you basically lose all of your progress, which means like you lose all of your like GPU cycles that you spend to run your workload. So how this problem actually been solved these days? Like it's kind of like a user responsibility or application responsibility to perform a checkpointing. So imagine like you have like your PyTorch script, and after like every epoch, your user has to like checkpointing the snapshot to the snapshot of their model. I think this is pretty much like how it usually how users perform it, but sometimes it cannot work because like every epoch might take like an old time, and also like they need to make sure this is on application level. They're making this checkpoint on application layer, so they need to change their PyTorch code. So what is actually like I've been exploring a little bit and how community try to solve it. They try to provide some sort of transparent checkpointing, where like we checkpointing more on a kind of orchestration layer, and there is a utility called Cryo. Like I don't know, maybe we can also talk about it more, um, because we have a few folks here on the call. But eventually, like this tool gives you an ability to snapshot the Linux process, which allows you to restore them when you want to when you want to restore your process from another job, which means like it's completely transparent from the user, and user doesn't need to do anything. Is happening everything behind the scenes. So maybe like Radisson, since you're also here on the call, do you want to give you like an overview of your talk and maybe what you've been working on? Maybe-
Yes.
yeah.
I guess a brief background about myself. I've been working on Creo it's pronounced Creo, checkpoint restoring user space. But I've been working on this project for about 6, 7 years now, and I'm one of the maintainers of the project as well. And I have some slides here that I can use to help explain how it works.
Yep. Yeah, sure. Go ahead.
Would it be possible to share my screen?
Yeah, I think you should. Let me give you permission. Uh, do you have permission to share right now?
Yes.
Yeah, go ahead, go ahead.
Okay. So we have been, so these slides are based on the KubeCon talk we had earlier this year in London. And essentially we have been collaborating with NVIDIA on enabling GPU checkpointing. And just to provide some background, checkpointing the state of GPUs is difficult because essentially we need to be able to essentially save the state of the GPU memory and the internal state of the driver and then to restore it back. But when the driver is proprietary, for example, in the case of NVIDIA, we can't really do that in user space. So essentially what Microsoft did, Microsoft have published a few papers. So they also use Creo for essentially checkpointing training workloads, and they describe how they essentially implement a proxy mechanism that essentially intercepts all GPU API calls and then keeps track of what memory is being allocated. And then essentially they provide a workaround of checkpointing GPU applications. However, there are some challenges with essentially this approach. So the first thing, it's very difficult to implement and maintain because you have to intercept every API call that the GPU driver will make. It adds some performance overhead. Microsoft have a good explanation how they optimize this, but essentially you have to track all API calls and you have to log memory transfers between the GPU and CPU memory. And it's also architecture specific. Essentially, you have to decode every CUDA kernel that is being loaded onto the GPU, and then essentially you have to re-implement most of the logic that NVIDIA have to essentially execute CUDA kernels. And it also works only with dynamic linking. So for example, most of the CUDA applications use static linking because they also integrate the CUDA runtime so that you can just execute your CUDA binary. But for example, you have to recompile PyTorch to be able to use this, essentially this interception mechanism. And so over the past year, we have been essentially integrating these checkpointing mechanisms with Creo. We use essentially plugins that implement the GPU checkpointing functionality. This works out of the box with Docker, Podman, and Kubernetes because Creo has been already integrated with these container runtimes. And we support both AMD GPU and CUDA plugins. So for AMD GPU, a team from AMD reached out to us about 2 3 years ago, and they essentially extended the Linux kernel with essentially API calls that allow us to save the GPU state and to restore it back. And this is implemented entirely in Creo, but the way it works is the CUDA plugin interacts with the Linux kernel, and then it essentially saves the GPU state. NVIDIA used a different approach. So they implemented a tool called CUDA Checkpoint. This tool essentially checkpoints the GPU state into host memory, and then Creo will just save a full snapshot of the host memory, and this allows us to checkpoint and restore applications. And the way it works with Kubernetes, essentially, the container runtime, for example, Creo or containerd, will call essentially a checkpoint function within runc or crun, and then this will trigger Creo. Creo will create a full snapshot of the container, and we can essentially create a checkpoint image. So this is a standard container image that contains the checkpoint files, and we add annotation that essentially allows the container runtime to recognize that this is a checkpoint and then to restore this container from checkpoint. And so we did some evaluation to see how it performs during fine tuning. So we can see that it takes a few seconds to create. Essentially, it depends how fast you can transfer the GPU's memory to the host, but it takes usually a few seconds to create a checkpoint, and restore is usually faster. We also evaluated when scaling to multiple GPUs. So essentially, we have to checkpoint the state of every GPU and to restore it back. So essentially, if you increase the number of GPUs, the size of the checkpoint also increases and the time to create the checkpoint. And we also compare essentially what is the size of checkpoints. It's usually in the case of model training, it's usually the model weights are the largest component of the checkpoint. So the GPU state is up to 95% of the checkpoint size. And we released Creo version 4.0, which contains the GPU checkpointing functionality, and there is the CUDA checkpoint tool, which can be used separately to checkpoint restore the GPU state into host memory. I hope this provides a brief overview of what we currently have and how it works. But Andrei, if you have any questions or if you can provide me more information on what you're trying to do and maybe.
Yeah, definitely. Yeah, I have a few questions like before we jump to this. Like I see some question from Debunker. Debunker, do you want to ask your question?
Yeah, it might be a silly question. I was just wondering, like, how is it different from the checkpointing provided by the framework itself? Like, PyTorch has a package for like torch.utils.checkpoint. So what different are we trying to do through this? I want to
Yes.
understand.
So it's called transparent checkpointing because essentially we use a GPU driver API to essentially create a checkpoint at any point in time. So for example, you can create a checkpoint in the middle of training, or in the case of Microsoft. So Microsoft published a paper called just-in-time checkpointing, where essentially they describe how they can reduce the overhead of creating checkpoints. So essentially, it's a fault tolerance mechanism. You can either periodically create checkpoints, or you can try to implement something similar to Microsoft, where they'll checkpoint only the essentially they separate the CPU and GPU state, and when the GPU fails, they recompute only one of the workers when they have a distributed application.
Yeah, you can imagine. Yeah. Uh, Yeah, just wanted like definitely like users can leverage the utility function to do checkpointing. I think the problem is like it could be tricky for different types of training you want to run, right? And sometimes it really depends on your data. Like for example, if for every epoch you process like terabytes of data, like it maybe take like 1 day to finish your one epoch, right? Which means like it's really tricky for you to perform checkpointing there. So it really depends like on the use case you run there.
So basically, it offers more granular control.
Yeah. Yeah, and it's like fully transparent, right?
Another use case we have is with inference. So, for example, if you try to use VLM to do inference for, I guess, large language models, then the initialization time, essentially the time to start VLM it could be up to a few minutes. It's mainly because it performs some optimizations like CUDA graph capture and a few others that essentially take time. So you can create a checkpoint immediately after the initialization has completed, and then you can essentially start VLM from this checkpoint and reduce the startup time significantly. Like I did some evaluation experiments recently, so we can reduce the startup time from up to 1 minute to a few seconds. And yeah, this is one of the examples. Also, HPC applications are quite popular, so you don't have to implement the checkpointing mechanism in the application itself, but you can just use the check. This is now part of Kubernetes, so Kubernetes has a checkpoint API that can be used.
Anton, go ahead. You have a hands up.
Yeah. As far as I understand, I would say there are two main different use cases that's behind the question that are asked there, and I think like one is fault tolerance, and you've mentioned it just a few minutes ago, and so that with the container checkpointing is a different thing than what we are generally referring to at the application or framework level. Checkpointing here, you correct me if I'm wrong, but that's basically a snapshot of the GPU memory. Like it's an entire dump of the GPU memory. So physically, when it's persisted on disk, it's completely different format from what a framework like PyTorch would persist, or what like Hugging Face, safe tensor, or whatever format generally in the at the application level we are familiar with. So basically at the application layer, PyTorch, you would checkpoint in the sense that you would use that for serving or to push that to a model registry, for example, while with a container checkpointing mechanism, it's generally more for fault tolerance. Like you wanna use that as a how could I say, like you snapshot the state so that if a failure happen, you can resume it from that state. But I'm not sure you can take what's being dumped there, like, and use it as is as VLLM in VLLM, for example, in serving. So I think that's really two different things. So that's for the functional aspect. And the technical aspect, I think there are still few gaps that I think are worth mentioning with when it comes to model training and container checkpointing provided by at the platform level. That, as far as I understand, the solution for NVIDIA GPU, it relies on CUDA checkpoint, the library from NVIDIA, and it does not support multi-node training and also, for example, when you use Nickel as a communication backend, it's not supported yet. So that's just to keep that in mind. Like there are some limitation, and the last point that I would make is that when we discuss at what level, because I think that's the main question, what level should be done the checkpointing, whether it's application framework level or the container level, is that also the container level, you have to have the exact same topology from the moment you checkpoint and from the moment you resume. Like you have to have the exact same hardware, the exact same number of nodes, and that in some scenario it has to be, I mean, kept in mind, because sometimes it's desirable that you can accommodate change of topology between checkpointing and resume.
So actually, like on a multi-node, like Antonio, like I was checking like another talk on the KubeCon London, and I think those guys, they built an operator like to perform, the daemon set and all the, like changes that I guess you're talking about that is required, right, to perform checkpointing. I think during the demo they've been showing the multi-node checkpointing, if I remember correctly.
So yes, I mean, you can do, so this actually tool I created, Crew Coordinator, for my PhD, and they use it. But yes, so what you said about Nico is true. So currently the CUDA checkpoint tool doesn't know how to checkpoint Nico jobs. And the workaround for this is to do what PyTorch does. So essentially there is a barrier that you can execute, and then you can create a checkpoint after that. So for example, if you try to checkpoint distributed training with Nico, what happens is the CUDA checkpoint tool tries to essentially lock the first worker node, and then this results in a deadlock. So the way you can work around this is by using a barrier similar to PyTorch. And they plan to fix that in CUDA at some point. So there are multiple people asking for this functionality. The other thing that you mentioned about topology, it's true. So essentially, if you checkpoint on, for example, two H100 GPUs, you have to restore on two H100 GPUs. You cannot, for example, checkpoint on one GPU and then restore on a completely different one. It's mainly because the way they describe this is checkpointing on x86 and restoring on ARM64. Essentially, it's the same challenge. So it's very difficult for them to make something that works across different GPU architectures. But the other thing is the driver version. So you have to use the same driver version during checkpoint and restore. So if you upgrade your driver, essentially you won't be able to restore checkpoints. But one of the use cases we demonstrated at KubeCon was migration. So you can essentially checkpoint on one node, and then you can restore your application on a different node, essentially using this functionality.
So when you say this barrier from PyTorch, right? So does it mean that, user is responsible to perform these barriers, or how does it work then?
Yeah, this is actually part of my research. So I'm currently creating a prototype on how to use that.
Okay.
Yeah, the barrier thing is interesting because to get a valid snapshot or checkpoint, you can do it asynchronously except but the moment the optimizer roll out the update to the weight. You can do a checkpoint when it's in the forward or backward path, but you cannot do it in the optimizer phase when you have an inconsistent state for the model is in an inconsistent state. So you have to have a synchronization mechanism between the main CUDA stream and the operation that does the checkpoint somehow.
Yep.
And that is unclear to how like a transparent solution like container checkpointing can achieve that.
I guess you need the application to essentially trigger the checkpoint at the end of an epoch or something similar. Essentially, you need to either instruct the application or have the application trigger the checkpoint. This is
Yeah. So it's yeah.
I just
That's very interesting.
Yeah, I just want to follow up on the other thing that you mentioned, the difference between essentially what Microsoft call application level checkpointing with PyTorch and this the transparent checkpointing they call infrastructure level. So essentially, if you're a Kubernetes operator, if you don't have control to the source code that is running in the container, you can't really tell the PyTorch application to create checkpoints and how often to create checkpoints, but you can still use this transparent checkpointing functionality in Kubernetes to essentially, for example, evict pods without terminating them. You can, for example, checkpoint the pods and then restart them on different node. Or if you have a long-running application, you can periodically create a checkpoint, and if it fails, you can restart from the last checkpoint.
Yeah, that makes sense. And the changes, I guess, so the changes is required for control plane to make it work. So there is a daemon set, right, which we need to run on the nodes, right? And I guess like we need to also have an images, right, which can pull the checkpoint from. So the checkpoint by itself, we need to store it somewhere, right? But there also is like, what is the size of the checkpointing that we need to store?
So the size of checkpoint usually depends on the application. So it contains a raw snapshot of the application memory. So this is, for example, if you have application that allocates 80 gigabytes of GPU, then essentially you're saving 80 gigabytes of GPU of memory. And this is usually the largest part of the checkpoint. We're currently working on compression mechanisms. So we're trying to integrate compression in Creo and encryption so that we can both compress and encrypt the checkpoint data.
This is where I think like it has to be said that it's a completely different kind of checkpoint that the application level checkpointing. When we talk about model checkpoints in the application level, generally that's only the model parameters and a few other like state, like the optimizer state and a few things. While in that transparent solution, it's an entire like file system and memory space that's being dumped on disk, and that contains much more than what is generally needed for what we are used to call model checkpointing.
Yeah, like a data set, for example, right? Because you need to store this in GPU memory when you feed like tensors to GPUs, which means like all this, memory you have to save in a checkpoint, right? If you like, process a large data set, for example, right?
Yes.
Yeah.
So, for example, Creo not only stores the GPU memory, but if you have file descriptors, it will save all open file descriptors, TCP connections. So it contains a full snapshot of both CPU state and GPU state.
Yeah, that makes sense. Any other questions from folks? Like I have a few of them, but so I'm more I think Russ, if you're talking, you're mute. We can't hear you.
Yeah, I think one thing that would just help kind of think explain maybe some of the value and some of like, let's say the complexities is kind of walk through a full case. And I'm not saying we do that now, but I'm saying as we go and discuss this in other contexts, right? Like, let's say we have a checkpoint, right? And we have a checkpoint that is like explaining like, okay, what is the scenario where there's a multi-node training job running and there's some node failure, or there's like the ability to checkpoint around some type of event and then resume. Like, what are the common scenarios where that needs to happen? So I think there's like, okay, what is triggering the checkpoint and why, right? And what is the resumption flow look like? I think kind of describing kind of the conditions around why the checkpoint is valuable and with the different scenarios, I think contextualize a lot of these questions much better. So that's just, I think we don't need to dive into all those details now. I'm happy other people to ask questions, but I think it would help frame, I think, some of these things and like the technical discussions a little better.
Yes, I think the most common example is distributed checkpointing, where you have essentially distributed workloads. So the idea is that you can use transparent checkpointing for every workload. And if one workload fails, you don't have to restart all of them. You can essentially restart only the one that has failed from the last checkpoint. And then you can essentially resume execution and continue for all of them. This is essentially the main use case that Microsoft have presented in their paper. But there are many other, like there are multiple people using, multiple companies using checkpointing. So for example, reducing the time to first token for inference is another use case. For example, I think MapWorks are also using it for scaling. So for example, if you want to scale a workload, you can create a checkpoint and then you can scale your application from this checkpoint. And these are pretty much the main use cases. And migration is the other one. If you have application, for example, with high performance computing, you have sometimes simulations that run for long periods of time. And for example, if you run something for weeks on expensive GPUs, if you essentially kill your pod and lose all the progress that has been made, will be very expensive. So using this checkpointing mechanism will be valuable in this case as well.
That makes sense, because I think like that's what I assume. Like, there's a huge kind of cost component here, like trying to not only speed things up but make things cheaper. Like once you've used the GPUs for hours and hours or days and days, you don't have to restart the whole workload. So I think that context I think is generally clear, but I think this is helpful, like breaking down into the various use cases to think about them in different with the different technologies sitting on top, right, at the application layer, whether it's inference or training. So yeah, no, thanks for that.
And also Microsoft included some cost estimation in their paper. So they say something, it saves them a few $1 million every month, this checkpointing mechanism.
Yeah,
Yeah, I think the
I think
spot
that's
is,
huge.
yeah,
That's
also
huge.
could
Like
be
to
huge, right?
understand that business value. Oh, sorry, Andrew.
Yeah, I mean, using spot instances, like, this obvious value, right, that you can get immediately, right, and they're much cheaper, right, compared to on demand. So
Yes, we actually had a company called Two Sigma. So it's a hedge fund company. They used spot instances to essentially reduce computation, the cost of computations, and they contributed to the Preview project to essentially create a more efficient way of streaming the checkpoint files. So essentially, how you can evaluate to create a checkpoint more efficiently. Yeah.
Yeah, I think this is great. Like, I would love to for us to, like maybe see how we can integrate this within, within the runtimes, because we've been thinking about, what kind of capabilities we can uh, give users to perform checkpointing over job sets. Because yes, you can, I know there is an operator exist, but like the question is like how people can, just see this value and have an ability to trigger their, their Python jobs within the predefined, runtimes, which has all the, like required template for you to perform those checkpointing. So in terms of operator, so how many operators exist today? So are we talking about the same operator, like the folks from Microsoft that the talk that I shared in the notes, and the one that you're talking about in Cryo?
In addition to my PhD, I also work at Red Hat, and I've been working with Adrian Weber, who is essentially the main person driving the checkpointing functionality in Kubernetes. So our goal is to create something that is acceptable with the upstream community. So we are currently trying to create a working group for discussing the checkpoint restore functionality.
Yep.
We have an open source operator which essentially addresses one of the requests from the Kubernetes community, which has been how to essentially limit the amount of disk space that checkpoints occupy. So if you create a lot of checkpoints, you can run out of disk space. So essentially, we created an operator that will automatically delete checkpoints that are no longer needed, and we plan
Okay.
yes.
Yeah, go, finish your
We also have another project called Crew Coordinator, which aims to enable synchronization across multiple Crew instances, and this is in the case of distributed checkpointing. This is we have a Google Summer of Code project that is currently contributing to this work to essentially integrate this with Kubernetes.
I see. I think yes. I think that for us it'll be really interesting to see, like so those operators. So I guess like they require, like they have all the required, orchestration that you need to run. Because I saw like the talks like talking about some run C modification you need to make, right, to make it work, and the daemons that you need to run on the nodes, right?
So I mean, it's kind of complicated, but
Okay.
at this point you can use the checkpointing mechanism in Creo. The way so I created Creo Coordinator like 2 years ago, and my idea was to make it so that you don't have to make any changes in Kubernetes. And later on, after some discussions, we decided to essentially integrate this at the container runtime. So this is still work in progress, but yeah.
So any thoughts like, Antonio or Yuki, like, other folks, like, what do you think? Like, shall we explore more? Like, how this could benefit the exporter job that the one we've been talking about, or like, maybe any,
Yeah.
yeah, go.
The first question in the decision tree, I would say, is like to me it's different from the issue mixes like the two aspects of exporting the checkpoint in the registry
Yep.
for serving, for example, but you cannot do that for with a transparent container checkpointing mechanism. It's not a format that can be it's a memory dump, so you cannot use it with the LLM as is. Like, so that's one thing. Like, I think we should separate the question of the exporter, the model exporter. It's a separate question as far as I can tell. Not the question about the transparent checkpointing. It's more for fault tolerance or scenario. Actually, there is a good use case which is with Q, for example. When Q would preempt a training job, ideally there would be a just-in-time checkpoint performed at that moment, and then when Q readmit the training job, then it resume from that checkpoint. That would be a nice use case. But there, I think it would be great to have both. It's for sure the fact that it's completely transparent. It makes it very like attractive. But it feels like maybe there are some pieces to. Well, like I've seen that many people mention the fact that at the moment it's all happening at the kubelet level. So you don't have an API server to trigger the transparent checkpointing. You have to call the kubelet for each node on each node. And at the moment, it's all stored on the physical host storage, if I'm not mistaken. These are, I think, the thing that needs to be polished as well before it really can be a mainstream solution, I would say.
Yeah, that makes sense. Let me create a separate issue for this, and I think like maybe as the next step, explore the operators, and I think like Rodos knows like your work, right, in terms of coordinator, and I think if you can help us to link these resources, I think I know like you want to have a new working group, which also we can participate and see how we can drive this forward. Yeah, go ahead. Yuki.
Thank you for great presentation. As far as I know, the current Kubernetes has a container checkpointing mechanism, right? But the Kubernetes does not provide any kind of helpful interfaces, and they do not provide resuming mechanism. And my question is, so what is functionality differences between the current Kubernetes checkpoint mechanism and this CRIO mechanism? So this is the first question. And the second question is, that does CRIO create a reproducible checkpoint for model training? I mean, so I know sometimes, as someone mentioned, researchers and developers create checkpoint by Python library. But as far as I know, in the middle of training epochs, if we create a checkpoint against the middle of a single epoch, it is not reproducible checkpoint. So the second question is, so if CRIO creates checkpoint during training processes, is it reproducible in another node?
Yes, to answer your first question, I guess it was about the current functionality in Kubernetes. So we have an API at the kubelet level. So you can use, for example, curl to send an HTTP request, and this will create a checkpoint. The checkpoint is a tar archive that contains all checkpoint files. Then you can essentially convert this tar archive into container image. We have a tool called checkpoint CTO, checkpoint control, that you can use to do that. But essentially, once you convert it to a container image, you can just replace in your YAML file, you can replace the image with essentially this checkpoint image, and then it will automatically, Kubernetes will restore the container. So we added support in Containerd and CRIO to recognize checkpoint images. So this is how the restore functionality works. And your second question about reproducibility. So the transparent checkpoint is essentially a snapshot of the GPU state and the CPU state. So for example, during the KubeCon demo, we show that, for example, you can checkpoint BLM or OLAMA while it is generating text. And then if you resume, it will just continue generating the text from where it left off. So it's the same with training. In terms of reproducibility, it's essentially exact copy of the state. So did that answer your question?
Yes, thank you. So that's perfect. If I understand correctly, so for the first question, the current Kubernetes checkpoint mechanism and this CRIO checkpoint mechanism is mostly same, right?
Yes.
But Kubernetes does not provide a restoring mechanism, but CRIO provides a restoring mechanism from container image, right?
So the way we implemented restore was by essentially creating a container image that contains the checkpoint, and then you can use this. Essentially, what we're trying to do is we are trying to allow transferring the checkpoint from one node to another using the container registry.
If I may translate that, to the training operator, that means that when you want to resume from a checkpoint, basically that means changing the container image of the training job. It's more for the training folks in the call, like the.
Yeah, you need to mutate the new image.
Exactly.
Mm.
That's the mechanism that.
And you store
I see,
this image,
thank
I
you.
guess,
So-
in the node directly, right? On the node. So
It's worth noting that we had some feedback that essentially this takes a long time, essentially copying the checkpoint data into tar archive and then extracting it again is time consuming.
I think that, yeah, the trick is there, the images are immutable, right, today. So
You have to push basically. Sorry,
Yeah.
but basically something has to build a new image that adds
mhm.
a layer containing the tar from the checkpoint, push
Okay.
it to a registry, then let's say the train job, like for instance, for in our
Yeah,
case,
just
has to
make
use that new image.
basically the same image with a new layer, right? Which we
Exactly. Yeah. It's absolutely
makes sense.
yeah.
Makes sense. Yeah, and I know we don't have a lot of time. I just want to give maybe at least 5 minutes before I need to give overview for roadmap. But I think next step for me creating an issue, I think maybe exploring the operator that we have today. Like the coordinator and also the checkpointing CTL, like the one that is shared, and maybe see how we can make it more easy to use for for folks who are leveraging those train jobs, right? I think there still will be a lot of benefits for them running PyTorch.
The other thing is we decided to create a working group mainly because there were multiple people, multiple companies trying to collaborate on this feature. So in general, describing the use case with Kubeflow and the training jobs will be also very useful.
Yep.
It's mainly because we're trying to collect a set of requirements and how to move forward.
Yeah, definitely. They just ping us like when we need to, enumerate those use cases. Happy to join this discussion, provide more feedback. But thanks again for this great, presentation discussion. I think it's really interesting and exciting time to talk about it. All right, let's maybe quickly talk about the roadmap. So Annie, do you want to go ahead and just quickly give an overview what we've been kind of finalizing for the SDK?
Yeah, sure. Shall we create a new dedicated meeting for Kubeflow SDK?
Yeah, it's a good question. Yeah, it's a good question.
Cool. So,
Go ahead.
yeah, first of all,
Go ahead.
yeah. First of all, we plan to release Kubeflow SDK to PyPy soon once we get local execution mode in place. Yeah, ideally, we would love to have the automated release process by that time. So I'm currently looking at that and looking into Feast's automation release process. Yeah, so that's the first one. Then we also plan to include Kubeflow SDK into KFP requirements because there are a few benefits for that, such as we could use KFP UI as a foundation for Kubeflow UI, and there are a few more benefits. You can check out the issue Francisco has created and post your comments if you have any. Then also regarding the test coverage, we've got, and feel free to interrupt me if you have any questions. We've got some unit tests and end-to-end tests already in Kubeflow SDK, but feel free to add more tests as a first time contribution. It'll be really great. Yeah, then we have a generate docs for Kubeflow SDK. I think that's more for trainer SDK and Ktype SDK, right? So currently we have the manual created docs, but I think that we want to automate the process of generation of documents similar to what KFP, Feast, and Malware Registry do. They use Winx for that. Yeah, so we'll need to create some CI jobs that will automate this document generation, as well as whenever there are new changes to the code, it will automatically change and update the documents. Yeah, then a few items for trainer SDK. First of all, we have already migrated the trainer SDK to the Kubeflow SDK. And then the next item is the local execution mode that we are currently working on, and hopefully we'll get it merged soon. So we will initially provide the subprocess, Docker, and Podman functionality to allow users to train their models locally with no clusters.
Yeah, so sorry for trying, like, just a quick question. So we think we can finish it, ASAP? I know Sat has been working on this, but he hasn't really finalized the latest feedback.
Yeah, I think Sat he was in PTO for 2 weeks or a few more weeks. Yeah, but he's coming back tomorrow, and I think he will be pushing this ahead. And then we have some folks like Brian. He will contribute to Docker and Podman functionality as well.
Yeah, I would definitely need more feedback on this. Like I leave my comments, but please take a look like for those who can help us. Like eventually want to give users ability to run trainer locally without Kubernetes cluster. I think it's, we want to release as part of the, first release. Yeah, go ahead.
So if I remember correctly, in the last year, we tried to create a mechanism for auto generation SDK documentation in Curtin project.
Yeah.
In the Google GSOC project, right?
Yep.
Andre, so did you remember how is progressing against
Yeah,
the
yeah,
project?
that's right. So yeah, Shiva was working in, but we didn't get chance to finalize it. So and if you want to take a look, like I can link you this PR. It's like in progress, and it says almost everything. We kind of agree on the tool. We agree like how we can do it, but at least like we can maybe reuse some of those assets for dogs generation.
That would be great. Yeah, thank you for letting me know.
Yeah.
Cool. And then go ahead, Yuki.
So additional one is multi-cluster supporting. If they can use KQ project, I think they can leverage the KQ mechanism because Q records the nominated cluster name in the Q workload resource. So I think Kubeflow SDK can obtain cluster name from the Q resource, Q workload resource, and then Kubeflow SDK can select which kube config should be used in the training job submission process. Yeah, this is just a comment.
Yeah, I think it's a great point. I think like, if we can at least for social functionality with multi-queue to support multi-cluster management of train jobs, I think that's would be really useful. Because I guess like we just can get this information from labels, right? Because there's still like the only requirements for you to have a kube config, right? Which can access all those clusters. That's it, right?
Yeah, Q has kube config information in the multi-queue cluster CLD. So
Okay.
Kubeflow SDK can obtain information from the secret. Yeah.
Yeah, that makes sense. Makes sense. Yeah, I think that makes sense. Go ahead, Anya. So,
Yep. Cool. Thank you. So we covered the multi-cluster environment as well. Then the next one is snapshot users for Express. Yeah, it will be because currently you can only provide one individual Python function to the train job, and it will be really great if we could capture and reproduce the entire development workspace to the train job. Yeah, the next one is support distributed data cache configuration via initializer SDK.
yeah, I think this is what Akshay is working on. I think like for snapshotting, we definitely can think about it once we have time. In terms of how we can. I know there is some modern PRs how we can support more than one Python function, but eventually yes, we need this functionality to package the user code to the job without creating the image, right? It's yeah.
Cool, thank you. And then also for built-in trainer, we currently have only TorchTune, which has been deprecated and there will be no functionality. So Xiao has proposed 3 options. Feel free to check out this issue and share your feedback or suggestions, whether we should continue using TorchTune or create a dynamic built-in trainer and so on. So that'll be good to also manage for the next year. Yeah, and then also it will be really great if we could migrate or include Ktype SDK and model registry SDK as well to Kubeflow SDK and potentially KFP as well. Yeah, so that's been the roadmap that we came up for this year for Kubeflow SDK. If you have any other ideas, please share it with us. I've got a few items, but we are running out of time.
Yeah, definitely. I think it looks great. Definitely like we can, I think we should merge this initial version and push this forward. I think eventually we should, give more folks visibility around what we do within Python first experience. And I think, as we discussed, I think last time, having KDIP as the kind of first version before we migrate maybe makes sense. So folks can quickly see, hey, how we can tune models, so they can also optimize parameters, everything using just a single, Kubeflow Python package, right? Without a single place. On the model registry, I think let's definitely have a conversation. Because I want to hear, more feedback from those guys, how they see the migration, etc. But I think KDIP could be, good candidate for us. Maybe once we support Shrine job within KDIP, we can have an ability for, just provide ability to kick off the KDIP jobs within train jobs, right? Because today you cannot run train jobs within KDIP experiments, which we need to work on. Yeah, I know. So I know we were time. So I think like we probably let's follow up on Slack if we need another meeting for SDK. I think maybe if we want to have more conversation, maybe we can have like weekly meeting for SDK, weekly meeting for trainer. And I know there is also like some discussion around experiment tracking and JAX and LLM, or, the GPU infrastructure. Let's talk on this as well on the next calls. We will try to look at more time to talk about those things. Any last questions, comments that you want to quickly talk about before we wrap the call?
Yeah, I just wanted to quickly mention that Matt yesterday he mentioned regarding experiment tracking, and we're currently working on providing it and proposing it. So please reach out or please check out the pull requests, the proposal. It will be good to get the idea and your thoughts on that because we are currently working on some of the proposal for Kubeflow SDK as well in experiment tracking terms.
Yeah, definitely. I think definitely take a look at this experiment tracking cap. I think it's extremely useful across all of those projects that we work on, and it's unified, experiment tracking solution across all those projects, that require access to this. All right. Thanks everyone for your time. I'm sorry, like we didn't get a chance to talk about, other topics, but let's follow up next week to, talk about them. And I think like for JAX, we can definitely follow up for CAP, similar to GPU infrastructure there. All right. Thanks everyone. Thank you for the great presentation, and I guess see you next week. Thanks.
Right.
Thank you. Bye.
Thank you.